Hello, we are Sheet Engineering from Heriot-Watt University in Edinburgh. We are a group of master's students investigating the sustainability of wind energy in Scotland. We have consulted with many stakeholders and found that onshore wind farms have numerous problems associated with them, such as unsuitable land, visual and noise pollution, and delays in approval. These all hinder the ambitious goal of Scotland reaching net zero by 2045. Despite best efforts to develop a solution to combat these issues, with the advice of our stakeholders, we have moved to developing an offshore solution which we hope would have a more effective impact on reducing Scotland's carbon emissions.
An energy island would be one way to override the issues mentioned with onshore wind and would help in achieving sustainability targets which the North Sea Transition Deal recognises will have to use emerging technologies. Energy islands are hubs for offshore renewable energy connection and storage. They facilitate offshore wind to be constructed further away from the land, where wind is stronger, turbines can be bigger and more efficient, and public nuisance is less. These hubs can be built on existing islands or man-made islands, which connect to surrounding wind turbines and other renewable energy. On the island, the energy can be processed and transmitted to countries on demand very efficiently.
For the early stage proposal, 3 main areas of Scotland were researched as potential hosts for the energy island. Both Orkney and Shetland were considered as existing islands that could be transformed into potential energy islands, as there were many locations that were uninhabited and fulfilled the size requirements of a typical energy island. Areas off the North Sea, off the coast of Aberdeen and Edinburgh, were also researched as potential locations for a man-made energy island, as there was existing oil and gas infrastructure in these locations and large pipe networks, both of which would be incorporated into the design.
Firstly, we looked at the feasibility of using an existing island in Orkney or Shetland. Both Orkney and Shetland are situated within a water depth of 50 to 100 metres and a wind speed of 15 to 20 knots, which are both suitable for energy islands. The sea surrounding the islands is predominantly protected for marine wildlife, which may pose an issue when proposing the construction of an energy island and a large number of turbines in the area. The offshore infrastructure around Orkney and Shetland includes multiple wind farms and some oil and gas pipelines. There are some connections to the mainland, but notably fewer than Aberdeen. There are many small airports around Orkney and Shetland and many harbours, which is essential for the transportation of material and personnel for the island construction and maintenance. There are many suitable islands around Orkney and Shetland, which would be suitable for an energy island at first glance. In Orkney, there is a small, presumed uninhabited island off the coast of Flotta, with an oil terminal and pipeline running close by. 1.5 miles northeast of Shetland is a small island near the village of Mossbank. This island is uninhabited with an area of around 190,000 square metres. There is no online information provided about the island's usage, so it is assumed that the island is not an area for tourism and wildlife, making this a good location for an energy island.
We then looked at the possibility of an energy island off the south of Scotland, connecting to the city of Edinburgh. There are several existing islands near Edinburgh, however these are too close to land and are home to historical buildings or nature reserves, making them not suitable for new infrastructure. In this case, an artificial energy island would be constructed up to 100 kilometres from shore in the region of existing and planned wind farms, allowing for future turbines to be further out to sea, harnessing a larger energy production area. There is oil and gas infrastructure beyond this zone, however the established pipelines do not link to Edinburgh. These could be connected to the island for renewable energy production in the future. Attention will be paid to these ecological zones, and investigation will ensure that the island has minimal negative effect on sea life. The area has several major ports with well-established transport links to major roads and cities. The Port of Leith in Edinburgh is currently investing £50 million to construct Scotland's largest renewable hub to accommodate offshore wind growth. Grangemouth in Scotland is largest container terminal, feeding operations around the UK, Europe and the world. This would assist an energy island project.
We then looked at the feasibility off of the coast of Aberdeen. Aberdeen has a well-established energy sector and is home to Scotland's oil and gas industry. It holds a unique supply chain, so transportation throughout the city is already established and would be really easy to utilise. Most of the seabed off the coast of Aberdeen sits between 40 and 200 metres in depth. Since offshore wind turbines can be constructed in depths of up to 60 metres, there's a large percentage of the North Sea off of Aberdeen that can be used for turbines. Aberdeen has a huge amount of existing oil and gas infrastructure, whilst also having great access to pipeline networks. This indicates the high potential in being able to utilise the existing infrastructure and pipe networks when designing the energy island. The marine regions identified off the coast of Aberdeen are the Moray Firth and the North East areas. These are confirmed by the Scottish Government to not only have the highest amount of platforms, active, abandoned and no longer in use, but also some of the greatest lengths of pipelines, meaning these areas have great potential for the energy island. Along the coast of Aberdeen, there are a few marine protected areas, as shown in this map. The furthest protected area sits at around 88 kilometres from the shore. This means that anything over 88 kilometres would be suitable for the turbines.
To determine the most suitable location between the Scottish Islands, Edinburgh and Aberdeen, a simple options appraisal was carried out using a ranking method. The research detail has split into 10 categories and given a score from 0 to 5 for each location in terms of suitability for an energy island, with 0 being most unsuitable and 5 being the most suitable. After reviewing all options, it has been decided that Aberdeen has the best potential for the energy island due to its established offshore network, land connections, transport and existing infrastructure, as well as wind speeds, far proximity to protected areas and seabed depths. Moreover, Aberdeen has significantly better proximity to existing wind farms and oil and gas infrastructure when compared to the other areas, which will reduce the economical costs and carbon costs. Aberdeen has a net zero vision, planning to transition from fossil fuels and becoming a world leader in renewable energy.
Our next steps will be to begin designing our energy island, including the island dimensions, the use of existing infrastructure and how this will be done, the materials and aesthetics for the island, connection details, type of energy which will be utilised and details of this, transport links, technology which will be used and the potential energy capacity and energy storage solutions, alongside the construction details and economic and carbon costing.